Hello everyone, it's a pleasure to be presenting my project today, which aimed to answer the question, can robots act in a socially acceptable manner in day-to-day environments? What I mean by socially acceptable in this context is the interpersonal distance a robot maintains when interacting with individuals. The study behind how we, as humans, use space is called Proxemics, and was studied by Edward Hall, who drew up four basic proxemic regions: intimate, personal, social, and public, together with the factors affecting them, such as gender, age, and culture. In this paper, aside from answering the previously stated question, we were also keen to explore the extent to which cultural background influenced an individual's preferences regarding this issue. The reason behind performing the experiments with a robot is due to their common usage nowadays, especially in household settings. In this case, we use the COZMO robot developed by Anki, as its main purpose is to act as a companion. However, it's not capable of judging current societal rules, and therefore, the aim was to see if it could be taught these. The project is relatable to current work in industry, as the field of ethical AI is ever more prevalent today. However, this project is unique due to the reduced size of the robot being used. A prime example of recent work in the area relating to the ethical and societal views of robots is the paper written by Rolf and Crook for the ICDL 2018 conference, and they investigated how robots performed socially debatable actions which humans themselves couldn't classify as moral or immoral. They suggested emphasizing the need for social reward mannerisms, which were more complex than the current reinforcement learning techniques. Furthermore, there are papers like the one written by Stark. This paper had Baxter trespassing people's intimate space. Baxter is a large robot, and the majority of the respondents of the surveys say it was an intimidating experience. COZMO, on the other hand, is a much smaller robot, and one of the purposes of the investigation was to compare whether this made an effect on people. Furthermore, with the recent pandemic that we are all currently facing, proxemics becomes an even more important issue, mainly because we as people now are more conscious of how we approach situations when we communicate with others, and our behaviors have changed. The development of the solution was done using Q-learning, which allowed for the best action in a given environment to be performed. In this case, the environment consisted of three states, and these were a close state, an optimal state, and a far state, as well as four actions which could be taken in each one of these states, which included staying idle, moving forwards, moving backwards, or greeting a human by saying hello, how are you? Despite the labeling of these zones, the robot had no previous knowledge on which one was preferable, mainly because the rewards given for each action in a single state were adapted at runtime based on an individual's personal preference, and providing such a diversified environment allowed for the human to identify these preferences to a larger degree. Implementing this required the usage of Cosmos SDK, which provided functions like facial detection with 3D pose estimation, which were then used to calculate the distance between the two entities and then map to a state. Once a state was identified and an action was carried out, the user was asked for feedback with the cue, "What did you think?" This question was to be answered by speaking into a microphone, and one could say either "Cosmo good", "Cosmo bad", or "Cosmo okay". These words were then processed via the means of an asynchronous blocking call, which would perform speech recognition using the Google Speech Recognition API. Interactions between the robot and the 15 individuals who participated in the experiments were carried out in two distinct phases, namely training and testing. Each interviewee was subjected to both phases, as the initial training phase involved performing 15 actions at random to explore the environment to the greatest depth possible. Once the 15 initial training runs were completed, the trained policy was then tailored to the user's preferences, and was followed on and demonstrated in the following 15 iterations. Once the robot's behavior was showcased, the experimentee was then asked to fill in a questionnaire asking them to describe their experiences and fill demographic data in the way of age, gender, and ethnicity. This questionnaire was based off of the Godspeed questionnaire and mainly focused on the anthropomorphic, intelligence, and security aspects of the robot. The data collected showed that the respondents all formed part of the 20 to 25 age bracket, with a ratio of 2 males to 1 female, all of which coming from different backgrounds, including Indian, Spanish, South American, and British. The first conclusion that was drawn was the fact that those who were familiar with machine learning and its concepts, which were a total of 8 respondents out of 15, were not surprised by the robot's intelligence. 93% enjoyed their experience with COZMO, and 80% rated him conscious rather than unconscious. In terms of security, 87% thought that the robot was not intimidating, and 40% considered COZMO invaded their personal space, all of which were people from Southeast Asian background or British backgrounds. Aside from the numerical figures, qualitative responses were also obtained, in the sense of trying to increase the environment size, the robot trying to show more politeness in the way of saying thank you, for example, or increasing the volume of its tone. These results led to various conclusions. The first one showed that the size of a robot plays a crucial factor in the trespassing of one's personal space. In this case, 40% of the individuals thought that COZMO invaded the personal space, as opposed to 82% in the Baxter experiment carried out by Stark. What contributes to this is a human looking down on the robot, which makes them feel more dominant. Cultural background also had a large role in determining an individual's attitude to proxemics, which is something that was predicted. Those of Hispanic origin liked closer interactions, as opposed to those of British and Southeast Asian descent, and these observations fit in line with their cultures.
In terms of the future for this experiment, the first idea would be to expand the experiment to a larger audience, and not just 15 people. It would also be interesting to increase the age scope for the project, going from 10 years to 70 years old roughly, as age is known to have affected proxemic experiments in the past. Moreover, the split between males and females has to be equalized. Once again, this is because women can react differently to men, and this was actually seen in some of our experiments. Another suggestion would be to increment the state space to fit in both more actions and states available. This would be possible by using a more complex structure, such as a deep queue network, which would be able to handle a larger complexity of a solution by using a neural network in the background instead of a simple queue table. The final area to explore would be the difference the pandemic would have on these results. The most interesting experiment would be to compare the views of people before and during the pandemic, before being something that we've done, and during, which could be something that's carried out now. Mainly because personal experiences could have changed the behaviors that we currently see. For example, those of Hispanic origin are now forced to wear a mask by law at all times in their countries. And it would also be interesting to see whether people would do the experiments with a mask on.
In the following slide, we show how we carried out this experiment. And in this case, we can see that, to begin with, we see that COZMO starts by looking at the current state that it finds itself in. As we say, it recognizes it, and then follows on to proceed to do an action. In this case, it just stays idle. It then receives its feedback as it just and can accept it, after which the following iteration is carried on with. In this case, it stays in the same state and decides to move forward as part of its random experiment. In this case, the feedback is not so good and it takes it on board. This video was able to show roughly the experiment that we carried out and the purpose behind it. Thank you very much for listening, and I hope you enjoyed the paper, and I'm willing to answer any questions that might come along. Thank you very much.